Hello everyone, and welcome to the second webinar of AWS Solutions Architect, a short course presented by IT Masters on behalf of Charles Sturt University, or CSU. My name is Guy Coward, and I'll be your MC. Your mentor is Scott Farrell. Let's get the usual housekeeping done first. We encourage the asking of questions and the use of chat during the webinar, and there are two ways to do so in Zoom. We ask that you direct all course content related questions to the Q&A section and that you send all administration type questions to the support team in chat. And you can find the icons for both at the bottom of your Zoom screen. You can chat with panelists only or to your fellow students as well. And you can make that choice by toggling through the drop-down box once you've opened the chat log. I always suggest setting it to all panelists and attendees so we can keep everyone in the loop. The reason I say that is there are usually some very experienced industry types listening along who will be most helpful with any queries you may have and often have great insights that will augment whatever Scott's lecturing on. Zingers are always welcome, of course, if they're clean, and we will have a Q&A session at the end of the webinar. If there's a particularly relevant question, I'll interrupt and we'll talk about that. As usual, Angus and Barry are around tonight in an administrative and technical support role for IT Masters, and they're responsible for the Moodle page, learn.itmasters.edu.au web. That's our website, which is where you'll find the other materials needed for this course, labs, discussion forums, and quizzes. The quiz for this week will be available at the end of the webinar. Last week, I told you someone from CSU would talk about CSU broadly and about the cloud study options we offer together. I'm sorry, but unfortunately, given the public holiday for much of Australia, we'll have to postpone that to next week. The upside is that just means we have more time with Scott. So can you please put down your fidget spinners and Tamagotchis and welcome back Scott Farrell for another week of wonderful AWS chat.
Thanks, Guy. As everyone already knows, we're looking at storage tonight and what sort of options there is at AWS. So we're firstly going to look at what they are and how they're different, and then we're going to look at them a bit more in detail, and then we're going to have a look at some use cases, and we've got a bit of a demo in the middle there somewhere. So demos are always fun, aren't they? So we're looking at data at rest. We want to better understand the options, and it's important to understand what the options are because a lot of the questions that come up in exams and the certification is matching of those options with the requirements. So you can't just pick what you like. You've got to really think about matching that requirement. So this is just a little matrix that I've made up. So there's largely two file-based storage options, S3 and EFS. And block-based, which is EBS and the local or the instance store. It's sort of called two different things at different times. And we're going to drop down into these. So when I talk about file storage, we're storing a whole file at a time. So this is more like a file server or a NAS server or an FTP server, or like a Windows share. So you're largely handling the whole file at a time. More often than not, you're going to read from the start to the end of the file. That's called sequential access. And you can do some random access, but it's limited and it's usually slow. So you usually try to avoid it. It's very good for backups, very good for large files. And if you've got a lot of servers, if you're doing horizontal scaling, and we talked a bit about last night, then you're going to need usually you need some file storage to go with it. So S3 and EFS are both examples of file storage. Next one we're going to talk about is block storage. These are more like physical disks. So if you've got a disk in a machine, a local machine or a server, they're block storage, and they're more like a C drive, and you need to format them. And you usually format them as NTFS. So that's how you'll know that it's block storage, because you've got to format it. And it allows random access to files. It allows multiple requests at once, which is, these things are where file storage struggles. So this is the strengths of block storage is multiple requests and random access. Generally, it's more flexible in what you can do with it. It's good for databases or lots of small files, which is where the file storage falls down. And the local instance store and EBS are examples of block storage. So you need to be clear that how they're different. So this is also more like a SAN LUN or an iSCSI LUN. And because then you've got to format as NTFS. So you just got to make sure that you're clear about when the question is talking about files or it's looking towards something that needs block storage. You can store files on your block-based storage, and you can do random access on your file-based storage as well. But if you go the wrong way, it's poor at it. So if you were trying to put loads and loads of large files on EBS, it will work. But that's not what it was built for. Same as if you were trying to do random access to files on EFS, it will work, but it will be slow. So you try to avoid it. Okay, so we're going to have a bit more detailed look at S3. As we talked before, Amazon call it an object store, and it's really just storing. It's really just a file storage. So objects are files. So they call things just to confuse you a little bit. It's a higher level storage. It's abstracted away from the block, so you can't get to the disk. You can't format a disk. All you can do is upload and download files. You can program against it, and there's an API. We'll have a look at that in a bit more detail in the demo. And you can have many simultaneous clients. So it's definitely, you can have hundreds or thousands of people accessing the same file or folder at the same time, and you will have no slowdowns. It's not a shared file system, so but it does have shared access. It's nearly unlimited scale, and it's super reliable and super resilient. So if you've got any questions about if it looks like a file and it needs to be resilient then or reliable, obviously they're trying to point you towards S3. And you pay per gigabyte used, and it works out about a quarter of the price of EBS. Remember, we're not always trying to save money, but you know, if it's maybe 6 of one, half a dozen the other where you put the file, maybe S3 is the go because it's much cheaper. There is some limits to S3. The object or file size can't be bigger than 5 terabytes. Object count, how many files you can store, is unlimited. And the bucket count, buckets are folders. It's synonymous with a folder. And by default, you're only allowed to have 100 buckets, but it's one of these things you just sort of have to put up a support request and say, I need 1,000 buckets or I need 10,000 buckets. So there's no technical limit. It's just they put a sort of a sensible limit on it to start in case you accidentally do some coding and it creates 1 million buckets that you didn't mean to, and then they're hard to get rid of. There's just a link to about some performance considerations of S3 that you can have a look in your own time. The other thing I really like about S3 is the security. It's very granular, and there's a number of different ways you can do it depending on what you're trying to achieve. So you can authorize an EC2 instance by using IAM roles. So if you've got a web server that wants read-only access to a certain folder or a certain bucket, you can make an IAM role for that and assign it to the instance. So you have to. So if you set it up like that, the instance doesn't need any usernames or passwords or access keys or secret keys at all. It can just access those buckets and so forth without any security, which is actually more security because then no one can steal your access keys and secret keys. You can authorize applications either with the roles or using a secret key and access key. So that's like a username password. You can pass the security rights down to the end user, but to do this you need to use STS, which is a federated access. So if you're in a Microsoft environment and you want to store files on S3, and have their Windows permissions pass through, you can use SDS and some shared credentials. And you can also sign a specific URL so that if you've got the URL and the signature that goes with it, you can access the file. So we're going to take a quick look at, I'm going to do a bit of a demo. Obviously, you can use a browser to access S3, and that's in the lab. So I'm not going to spend a lot of time on how you upload and download files in the browser, because that's the straightforward way of doing it. We're just going to have a look at this bucket of mine called sfarrel. So bucket names are globally, need to be globally unique. So I'm the only one got this bucket name. Had it for a while. This is files from a different class. But what we're going to do is upload some more files. Let's see. Just going to move this over here. Okay. See, space OT masters into the S3 folder. Okay. So I've got a test file on this machine that just says, hello, this is a test file. And I've got an ls command. So I'm just going to run this. AWS is the command line. I'm going to run an S3 command. I'm going to ls, which stands for list in Linux. I'm going to have it list out this sfarrel bucket. So I'm just going to execute that. And it shows me pretty much the same thing as the web browser does. The next thing is I'm going to copy up a file. I'm going to copy up that test file. So AWS S3 CP, which is Linux for copy, test file. And this is the format of an S3 URL. So it's s3:/ up to the sfarrel bucket. And now if I list it out, we'll see the test file here up in the bucket. If I refresh this, we've got the test file. So that's pretty exciting, isn't it? Now the permissions I've got on this is block all public access. So all these files nobody can get to. So I think that's the next part of my demo, is to get the file. Oh, I'm going to cat the file first. So AWS S3 copy. There's the whole S3 URL for the file. That's the bucket name and the file name. And to stand it out. So I'm going to copy it to stand it out, which is just like the same thing as catting a file. So you can have a look at it. And you could pass that through, say, to MD5 sum if you wanted to work out the MD5 sum of the file. I'm going to have a look at my get command. So here's one way to download a file from S3 using HTTPS. So I'm going to wget that. That says wget output to the command line, and that's the URL for the file. And it says forbidden. Dun, 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 because access to this bucket, public disabled. So that's no good, is it? So I'm going to have a look at sign. So remember I said one way for security is to sign the URLs. So what I'm going to do is pre-sign this file, and by default it creates a signature that's valid for 1 hour. You can create the signature based on time or IP address or a few different other bits and pieces. But this now I can wget that file using that signature. And it's only pre-signing that one file. So there it goes. Now it works. It doesn't get the error. This is a test file. So you could use that in your applications if you wanted to give out a link to somebody and be it valid for a time period or to a specific IP address, rather than just allowing that bucket to be open to the public. It's just, you know, one other way to play with security of files. And AWS S3 help. You can there's also a sync command. So there's a sync command here. And so you can sync a local set of folders up to Amazon, and it will effectively be very similar to Dropbox then. But I didn't do a demo of that one. Okay, so that's my demo. Those commands are on the next slide, so you'll be able to have a look at these later on. And I really quite like this idea of pre-signing URLs. It's quite good for application development, giving out URLs, that are one-time use or for a certain time period. Okay. The next thing we're going to have a look at is EFS. So EFS is an NFS store. It's a Linux Unix network file share. It's a distributed file system, so many simultaneous instances connect. So this is aimed at when you're having a horizontal scaled out application that might have 20 or 100 EC2 nodes, and they all connect back to the same NFS store. It's a shared file system. And there's a newer thing called FSX. It's Windows based. I haven't mentioned this yet, but Amazon bring out technologies every couple of months. It's hard to keep up to date with how many there is out there, and the fact that there's FSX out there. But it takes about 3 years for technology to get into the certification tests. It takes them about a year to make up the question. Then they put it in the beta questions for a year. It takes them 6 months to mark the beta questions, and they have to update the main exam. So it takes 2 or 3 years. So in the certifications, FSX won't exist. So I'm just showing you now because it's a bit more Windows friendly. If you've got a Windows environment, it does the same thing. It's highly available. It's highly scalable. Now, I've had issues around scalability. It's sluggish for smaller files, and the locking's slow. You can pay per gigabyte, and you pay per throughput. And there's a credit system based on storage size. It's like all these credit-based systems. If you don't buy enough credits, it will stall and look like your application's broken. So you've either got to pay for enough credits or have a fair amount of data stored on there. So if you've got like 1 gig of data stored on there, your credit system is so low that it's nearly unusable. So you've got to be a little careful on some of these. I guess it's highly scalable if you pay for enough credits. So I think that's fair enough. It's highly scalable if you pay for enough credits. And the instant store, this is one storage that's sort of overlooked. It used to be quite important, but I think it gets used less these days. So a lot of EC2 instance types come with storage. And I'm just going to quickly show that because not everyone might be aware of that. AWS instance types. So these talk about the CPU, and these ACE ones are EBS only, so they have no storage. But if you have a look at these M5s for EBS only, but some of these, they come with storage gigabytes. So this is the instance store. So this M5D large has 1 times 75, that's gigabytes, NVMe SSD that you get to access. And that's the local instance store. It's physically attached into that machine, and you can do whatever you like with it. I don't think there's even credits on it. You can just hammer it and do whatever you like. So some of the bigger ones have got 4 times 900 gig NVMe SSDs. So that's pretty sweet. So they're physically connected to the EC2 instance. It can easily be lost and destroyed. So any data you put on there, you've got to assume it's going to get lost. When you store data on EBS, the volume can exist even if the instance gets destroyed or stopped. The volume persists on EBS and you won't lose your data. But on an instance store, if anything happens to that instance, your data just disappears. So quite clearly, if you stop and start an instance, you will lose your instant store. You cannot snapshot it. And if there's some sort of failover event at Amazon, which they don't usually tell you that happened to you, but if your instance is running on one physical server, say physical server A, and then that gets destroyed or goes offline, or Amazon have some problem with it, they'll just restart your instance over on physical server B, and your instance store from A will get lost. So there's a lot of ways it can get lost. So you don't put anything on there that you want, obviously, but you sort of think, oh, I've got this big instance with 4 900 gig NVMe SSDs. Well, I'll use that. That's a lot of storage. But like I said, you'll probably lose whatever data you put on there. It's good for temporary files or swap files. It's often SSD, and they're very fast. And it's sort of free because it comes with your instance. So don't recommend clients put databases on there. Don't recommend clients put their upload files on there. Maybe you could use it for log files if you don't mind them getting lost. But obviously, if you're trying to diagnose what went wrong and your log files disappeared, that won't help very good. But swap files, it's a pretty good idea for swap files or temporary files. All right, we're going to take a look at performance now. This is where it sort of starts to get tricky. If you haven't had much exposure to storage performance before, I'm just going to go through a few terms up front. This does get complicated, and if you are a bit of a storage engineer, then it's, I'm probably teaching you things you don't need to know. But anyway, so there's two different main performance things we're looking at. One is bandwidth. That's how much can be read or written in a second. Sometimes it's measured per user or aggregated, and it's usually measured with serial reads and writes. So serial, sequential, same sort of word. So when you're reading a file from the start to the end, you're usually measuring bandwidth. IOPS is the other thing we're looking at, and that's an acronym for input-output operations per second. So that's how many individual read and write requests we can do per second. So this is how quickly we can read one big file. This is how quickly we can do lots of little reads. And it's usually measured as random requests. And then just to make it even more complicated, there's a crossover between each. Things that come into it like queue depths, and it can get quite complicated. So, for example, if you push the IOPS too high and you've got a large block size, you'll run out of bandwidth. So it gets a little bit complicated. But we'll have a look at how both of these work and at our different storage types. So EBS, we looked at before. Remember, it was block storage and it's not shared. You can easily back it up with snapshots. We talked about that. And you pay for the size. You can use SSD or hard disk drive. Now, almost always you're going to choose SSD, and there's only sort of corner cases that you choose hard disk drive stuff, because it's much slower. It is cheaper, but it's much slower. But if you wanted slow access to files and you didn't care how quick it was, you'd normally be putting that on S3, wouldn't you? So if you wanted quick access and random access to it, you'd want it on SSD. So the cases where you'd use hard disk drive access these days is very few, but it's still, they do sell it. So some people must find a use case for it. GP2 should be your go-to default. That's your standard EBS. They call it GP2. And the opposite of the GP2 is provisioned IOPS for high reliable IOPS. The different instances have different bandwidths, but the IOPS are similar though. So you can have a look at the different volume types here. So if you've got a question and it's talking about high IOPS or you want reliable access, then they're talking about provisioned IOPS. And if you're just talking about fairly regular storage for EBS, it'll be GP2. Let's have a look at IOPS a little bit. So under GP2, it's a credit system. Most people don't know this, and they use it, and then one day wonder why it went slow. It's a credit system. You've got 100 baseline IOPS for EBS, plus 3 IOPS per gigabyte of storage added to the baseline. So if you've got 10 gigs of storage, you've got 30 IOPS from that plus the 100 IOPS. You have 130 IOPS, which is very small, but you do have a 3,000 burst IOPS. And remember, there's a credit system involved. So once you run out of credits, you end up back at the baseline. To give you an idea, 100 IOPS is the same as an old 7200 RPM disk drive. And I don't know if you remember how slow they were at booting up a computer or doing something. They were super slow. So if you end up back in the 100 IOPS baseline territory, you'll think your application's crashed. But you just run out of credits and you're back at the baseline speed. So you've got to be really careful if you leave your Windows swap file on the EBS GP2 volume, because if you start swapping, you run out of credits. So the main way to get around this is if you need a lot of IOPS, you go to provisioned IOPS, or you provision 100 or 200 gigs of GP2, so your baseline's a bit higher. I don't think it usually affects Windows so much, because you're going to allocate 100 or 200 gigs to a Windows C drive, because Windows sort of updates gobble up space all the time. But on Linux, for example, you only need, say, 5 gigs to install it. And so you think, oh, I'll just make a 10 gig Linux partition for my root drive. And you'll end up in a lot of problems with that, because you just won't have baseline. You'll think, oh, I'm on SSD. That's really fast. But you'll end up back at the 100 or so, 110, 120 IOPS. So the smarter thing to do is allocate 100 gigs and don't use it all. Or if you do need more IOPS, go to the provisioned IOPS. So just be careful of the credit system on there. And EBS provisioned IOPS. So I think they're a bit easier to understand. You can buy 1,000 IOPS or 2,000 IOPS or 5,000 IOPS. And people will ask, well, how do you know how many IOPS you need? Usually someone will tell you, the customer will tell you, the question will tell you, or maybe you start at 1,000 or 2,000 IOPS, and if your database gets too slow during the day, you increase the IOPS until you don't have issues with it. So where am I going next? Oh, okay. So I just want to make a point about sharing. So quite clearly S3 is shared, because many people can access S3. Remember I said EFS is based on sharing. So many instances can access that. So many users and many instances can access S3, and many instances can access EFS. But EBS is not shared. So only one instance can access EBS at a time, but you can shove Windows sharing on top of EBS and share it out yourself if you really want to. But I would shy away from that design, because what you're trying to do there probably save some money. And if that instance goes down, or you have a problem with that instance somewhere, anyone connected to that, any instance connected to that will go down. And you're probably sort of engineering yourself away from using one of these two where you should have been using them in the first place. So if you've got something that needs shared access, EBS is going to be the wrong answer. Even if you think you can technically do it, it would be the wrong answer. If you need shared access, the answer is one of these two. And obviously your local instance store is not shareable. You could Windows share that as well. But imagine that. Not only have we got it tied to one instance, it's temporary, it's going to get lost. So that'd be the worst answer of all time, I would say. I've got use cases to talk about next, but I might take a few questions about a few things just to break it up a bit.
Sure.
Alan asks, is there any limitations with data ingestion bandwidths? That's a good question, Alan. No, you can throw at them as much as you want, as quick as you want. And data going into S3 is free anyway. So you don't pay for the internet transfer for data going in, you pay for the storage. And I don't know if you understand TCP streams and latency, but if you're trying to upload to S3 in the US from Australia, it's really slow. You need to upload to S3 in Australia. It's much, much quicker. And there's a whole bunch of acceleration technologies so you can upload quicker. and so you can break apart your file and upload multiple parts at once from one machine. You can use CloudFront to help even upload it even quicker. There's some really big upload ways. There's Amazon AWS Snowball. There's questions about Snowball in the exams. I've seen that. So Snowball is they send out you a physical server that you can upload the data to, and then you ship it back to them, and they put it up to AWS. You used to be able to send them USB drives, but I think they've cut that out. And there's even a bigger Snowball that's a semi-trailer that they can ship to your office, and you can upload data into the semi-trailer, and then they drive it back to AWS. I don't know if they do that one in Australia or not. So there's lots of ways to get the data up to S3. What types of encryption and decryption do you support? Data in flight, data at rest. So there's a lot of, I didn't go over encryption tonight. S3 is the main places that you have encryption, and there's a lot of support for keys, and all the data uploaded is obviously going over HTTPS. So that's in flight, it's encrypted using HTTPS. At rest, there's a lot of different ways to manage keys, to have all your data encrypted on S3. And you can have EBS shares encrypted these days as well. So there's a lot of support for data encryption. I just didn't go over it today because you can only go over so much. Can you create the same bucket in different regions? No, bucket names are global. So that's pretty clear. Because you saw I created my bucket in Sydney. I know it's hard to see that, but then I can access it with the global name. I'll just quickly show you that because it sort of reinforces that they're global. Remember I had this bucket here and this file here. It's actually in Sydney. So HTTPS sfarrell.s3 AP Southeast 2. So that's its real name there. But when I did the demo, you'll see that I accessed it through, where's the demo? Where's the demo? Oh, no, somewhere here. Yeah, so when I accessed it in the demo, I just accessed it from s3.aws.com. So that's a global name, but it still found it on the Sydney one. So there's only one. This is a Sydney more direct answer URL, and that's a global URL. But it shows you there's only one sfarrell bucket globally. How do you mount S3 on your EC2 instance? That's usually a bad answer. It does work. For Linux, there's a thing called S3FS, but you'll find it slow, unreliable, dodgy, and it's not really what you're supposed to be doing. If you want a mounted shared drive, that's what EFS is for. So remember, we're trying to get what's the correct answer, not what sort of works. So mounting S3 on an instance is sort of working. It's not good. So S3 is more often, from an application point of view, a programmed API access, or you're giving out that signed URL that I showed you, and then you don't have to have it mounted at all. Is that EFS price 30 cents a gig is a one-time cost, or is it ongoing? It's monthly. So everything's monthly. So EFS is more expensive than the EBS. But remember, again, you're trying to give you the right answers, not the cheapest answer. Given there's S3 securities, why have there been so many data breaches? Yeah, so I will agree. There's been a lot of S3 data breaches because people are lazy. The URLs are easy to guess. I think there used to be defaults that had some buckets open, and now Amazon's changed them to defaults to the buckets being closed. I think there's just lazy security people running data, and but there's ways to audit your data and audit your S3 these days. So there's some automated tools to check that for you as well. PayLP is asking a question, which is recommended out of EVS, EBS, S3, so forth for AWS for databases like Dynamo? Now, good question. When there's a question about a database, the answer is always RDS, the specifically managed Amazon database instances. So you should be outsourcing the whole management of DynamoDB, because there is one at Amazon, the Amazon will manage for you. So that's the answer to that. But if you really have to put your own database on an instance, well, you want random access. So you can't use things like S3 or EFS, can you? And EBS is what I said a few times. It's random access, high IOPS and so forth, which is what a database needs. So if you have to put it on anything, it could be EBS. Can you get more IOPS out of a stripe, out of a couple of EBS volumes? Good question, Emil. That used to be a common thing people used to try to do. But with your credit system, it doesn't give you any more IOPS because you've got the same credits. It doesn't really help you anymore. What it does do is it gives you some better queue depth sometimes. And so if you know about queue depths and so forth, sometimes you do want more than one. So instead of having 4,000 IOPS on one drive letter, you got 1,000 IOPS on 4 different drive letters. It gives you better queuing, I think. So I'm going to go back to some slides. There's lots of good questions. I definitely want to get through to some more of those. I think the questions are good. I think the questions are showing people are thinking about it and thinking about, you know, what they've seen or their clients or what their project's about. Okay, so we've done the demo.
I think we're up to about 18.
Thanks, Guy. Yeah, we talked about shared and not shared. Great. So it's the use cases. So this is what you might use these different file storages for. So for S3, it's largely a corporate file server replacement. So almost everyone's got a shared S drive or something in their organization where if it doesn't go in the database and doesn't go in email, we'll just put it on the shared drive, S drive or whatever you might want to call it. And it just gets filled with thousands of files, and they're usually a bit of an ugly mess. But S3 is a direct replacement for that. So just as messy and just as many files. You can use it to sync like Dropbox. I showed you that command before. So if you've got a internal file server and you want to back it up to S3, well, you can use an S3 sync style solution. There's also let's put this slides full screen again. There's also an AWS storage gateway for corporates to use, and that does an automatic sync to S3 for you. Image and media assets for websites. So if you've got some videos or lots of graphics or images or really big downloads on your website, you could put them on your web server on your EBS volume. You could do that, and that's what most people sort of first off think, well, I created my web server, I'll put the files on the same spot. But if you're going to scale horizontally, all of a sudden now, each web server, say you've got 10 web servers, have got their own EBS, and if you upload a new image, it's only on one of them now. So then you need some way to share all those websites, get access to them. So one way is to put your images up on S3, and then you use your URL, your AWS URLs to access those. Archival storage, that's one of the really big uses. So if we have to keep files for 3 years or 7 years and we want to move them off our corporate file server, S3 is a great place to put them because it's pretty big, unlimited, and it's relatively cheap for corporates. Any files that are large, greater than a few gigabytes, it's a good case to have them on S3. So if you've got a question about, you've got a file that's 100 gig in size, where should you put it? EBS or S3, it's fairly clear because it's a big file. Put it up on S3. Files that need to be shared, S3 is sometimes a solution. So remember, you can get shared access from S3, but depends on what it is. EFS might be the better answer, but S3 is one way of sharing them. Backups, a lot of people use S3 for backups. And the big thing about S3 is it's super reliable. Once you put your data up there, Amazon, I've got all these 99, I think it's, there's questions around, I think it's 11.9% guarantee that you're not going to lose the file. You can have the file replicate to another region. So you can store all your files in Australia and have them replicated to the US in case, I don't know, whole of Australia goes down. But AWS internally do things like immediately store it onto 5 servers in 3 different availability zones, each of your S3 uploads, so they don't get lost. And they check them and compare them all the time. So if one file's damaged, they'll repair it from another copy. So Amazon does a lot of that behind the scenes to make sure that you've got really good reliability of your files. Now, use cases of EBS. So it's always your boot OS drive has to be an EBS volume. You often use EBS volumes to check out your code and execute it. In a corporate environment, you've got your code under source control, and so you download the code and execute it. That's usually on an EBS volume. You normally install software, so if you've got an application, you're normally installing that locally on your EBS volume. Locally, it's network attached, but it looks like local storage. If you've got some sort of distributed node storage, it's usually EBS. It's medium reliability, but easy to back up with snapshots. Someone asked about databases a second ago. Remember they asked about Dynamo databases? Now, if you really have to put a database on your instance, it's EBS is the answer, but almost always you should be pushing your customer or your business to use an RDS instance. That will be the better answer. And anything that's got high IOPS requirements, obviously is EBS. It's the only thing that does high IOPS. So some questions are really quite clear. It'll say blah, 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 high IOPS. So the answer is going to be EBS. You don't even have to read the rest of the question. Use cases for EFS. So again, when you need shared access, horizontal scaling. So sometimes S3 is the answer, but other times EFS is a better answer in that scenario. So remember, EFS and S3 are the 2 things that can give you shared access. Sometimes checking out code locally to EBS works. Sometimes using code from EFS is appropriate. All right. So, remember we talked about you could locally check out your code, but you could also have your code sitting on EFS to execute it from there. So there's 2 different approaches. What most people use it for, it's a general place to keep shared description management code. So if you want some code accessible to all your instances, you know, a lot of IT folk connect up EFS to every instance, so they've got access to some general tools and so forth. And I'd say it's medium to low reliability compared to some of the other solutions. So I wouldn't put files there. Like S3 is super critical for super reliability, but EFS is not like that. So, and I think we talked about the use cases of instance stores, temporary files, swap files. Checked out code might be okay, because that's temporary. If you're going to check out the code from your source repository and execute it, it doesn't matter if that's lost, because if you start up another instance, you've got to check out the code and execute it again anyway. So that's okay. And I'll remember that's least reliable. All right. So the labs this week are from Quick Labs. I'm not sure if I spelt that right, but anyway. And Quick Labs is really, really spectacular. So you don't even need an Amazon free account for this. You actually use Quick Labs Amazon account, and you go into the lab and you click start or something, and boom, they open up a real Amazon console. It uses their account though. And then you go away and follow the lab, and but you're using their credentials and their instances and their S3 for this week, and it's locked. So don't go and change the region. Don't think, oh, like I want to put my folder in Sydney and drop it down from AP from US East 1 to AP Southeast 3 or whatever, because it might not work. So and if you do find that you don't have access, it's probably because you changed the region or something like that. And don't expect, if you've launched an S3 lab, to be able to go and start EC2 instances, because they've sort of given you the count to use for the lab, and you know, you're not supposed to be using for too many other things. And all the assets and data and instances that you make during the lab will expire when the lab expires. I think they give you an hour or two. And after that, they just delete everything. So obviously don't put up anything that's important. And you can't sort of start the lab, do half of it now, and come back in a couple of hours and expect to continue. So make sure you've got a full hour that you're going to be able to dedicate. Otherwise, you get halfway through and you'll have to start again. But I really like the quick labs. So in the full course, we've got heaps of access to quick labs and a lot of them. And we're accessing a couple of them for the short course. Sorry, Guy.
Apparently that's QWIK.
Yeah, as soon as I saw that, I thought it was quick. I thought that didn't have the C in it. Thanks, mate.
It's QW.
QW. Oh,
yeah.
Oh, I was a long way off.
Well, serves them right. Beauty. Cool. How did everyone go? Just chuck a few comments in the chat. How'd you all go with your labs last week? Did you find them useful? Did you get into them? I'm sure there'll be plenty of...
Where does that come up in? Is it a different thing than...
there's an icon down the bottom in chat.
Right.
Yeah, very good exposure. They were good. Useful labs. Beauty. That's good to hear. Sounds good. Yeah, feel free to send feedback in with the email that comes after every webinar each week.
Yeah, I'm just going to answer some more questions.
Yeah, we've got plenty, of course.
I really enjoy these questions.
Yeah, they're cool.
Alan asks again, thanks, you mentioned it's free to upload. Does it mean it costs to download? Yeah. So once your files are up there, you pay for them to sit there, a monthly fee, and you pay for your data going out of AWS. You always pay for that. So whether it's going out from your instance or out from S3 or out from wherever, you get paid, you get to charge the same amount. And compared to other places, it's expensive. But remember, anyway, we're trying to do a good job, not a cheap job. So yeah, you get to pay for all the data going out of AWS. What about getting data back off S3? Bruce asks.
And also adds later on in a question a few minutes later, or any other storage type for that matter.
Oh, right. Yeah. Okay. He's got two questions. So to getting your data out of S3, you can sync it down with that S3 command I showed you. You can get someone to write you some code to download it. I think you can use the Snowball to download code as well, AWS Snowball, but you know, it's a sort of an uncommon solution. And to get your data out of EBS, it's harder to get it out of EBS, to tell you the truth, because with S3 you can just sync it. You just get a big PC and a big internet connection and sync it, and it doesn't take very long at all. But out of EWS it's a bit harder, because you've got to have that EWS volume connected to an instance. You have to have an instance booted. You have to have an application on there that will let you get access to the data, and then you can download it. So it can be quite a drama to get stuff out of EBS sometimes, especially if you want to get a mass amount of it out. It can be a bit of a problem. The AWS S3 commands, is that just a loadable package to get those commands? That's called the AWS command line API or something. I just guess Google that and you'll find it there. I use it from Linux, but I assume it's also, so it actually comes from AWS. They maintain it. I guess you can use it on Windows, I'm not sure. Can you monitor the IOPS? Oh yeah, you definitely can. So in your instances, there's two levels of monitoring. The monitoring you get for free and the paid monitoring. I'll just go to EC2, North Virginia. And this instance does nothing. This instance does very little, let's say. And on the monitoring, you can see the disk reads and writes here. If you go into CloudFront, no, not CloudFront, CloudWatch, you can do some more reporting in there, and you can actually do reports that show you your credits for IOPS and so forth if you're on GP2 and and so forth. So you can see disk read operations. Here you go. I spiked up to 150. I said it doesn't do much, but it spikes now and again. Can you replicate your storage to another region? Yeah, Craig asked, can you replicate? So there's some features you can turn on replication to another region. And yeah, as soon as your data leaves Australia or goes into the US or goes somewhere else, then you've got data governance issues that you need to look into. So if you replicate it to the US, then the FBI might have a look at it, for example. I don't know. I don't profess to know everything about that sort of thing, but I do know it's an issue that the corporate will have people to advise you on that sort of thing. Can we have elastic configurations for IOPS? No, you can't. A lot of the IOPS things only let you change them so many times, or only let you to change them up. So there's some rules about you can't like change it to 10,000 in the morning and then drop it down to 1,000 later on. They only let you change it down once every 24 hours or something. And so the credit system tries to help on some of that. Can you automatically pre-sign multiple files? The signing of the files, that's code. So you just have to get someone to write some code for that. Explain the difference between availability SA. This is a good question, Keith. So there's two sorts of SLAs on S3. So Keith points out there's one called an availability SLA, which I think is only 99.9, I think. And the durability SLA is the 11.9s, I think, 99.9999999. Like we'll never lose the data. So availability is your ability to download that data, your ability to access that data. So is 99.9% available. So remember when I did that wget command? So here, that wget command, that's me going via availability. So that's me accessing the file and downloading. That's called availability. And durability is the fact that they won't lose the file. So perhaps their networking goes down or something goes wrong and I can't access that file, but it doesn't mean they haven't lost the file. So they pretty much guarantee we won't lose files, but like we'll make it mostly available for you. Alistair asks, should that be after the lab expires or after the account expires? So on the quick labs thing, I definitely didn't misspeak. It's after the lab expires. So on the first S3 lab, it's a 1 hour lab. They think 1 hour is plenty of time for you to do it. And after that 1 hour, they just delete anything you did. They delete your folders and your data and say that's it. So that's what Quick Labs does. So you obviously, if you want to follow the lab, you can use your own account and then it won't delete. But I don't know. I like the Quick Labs. Would you be able to give a few examples of certification questions? Krishna asks. The quiz questions, I've tried to design them around some of the certification questions that I can remember and the styles of questions and the harder ones. So I think you'll find the quiz questions, not everyone got right, even if you know a lot of stuff. I've sort of made them a little bit tricky. So it'll be the same with this week. Zane asked, what sort of performance hit do you take on EBS during a snapshot? 0 performance hit. So with EBS, the data is copied in more than one place anyway. You take a snapshot, it doesn't interrupt your instance, and they do it in the background. So the snapshot's instant, but then they complete the job in the background, and they do it off one of the replica copies as far as I know. I've never seen any performance impact while you're taking the snapshot. Pale asking for a daily 1 terabyte data load to S3 based on custom defined metadata. Is it good to search objects within S3 or map a metadata? Almost always, all applications have some sort of DynamoDB or external index. That's exactly right. So that's almost what everyone does. Especially if you've got a lot of little files, you'll have the application knowing what they've put up there, and it'll remember all URLs and file names externally to S3, because S3 is not the fastest thing to look around. You saw my commands, AWS LS, that takes time to like execute this command. It's not fast. So that's a fairly simple, just show me the contents of a bucket. So some of it's not very fast. Can you automatically push files from one AZ to another? So I like your thinking, Akint, there, but I think you actually asked regions. Sydney and LA are different regions. But yeah, there's a feature that you can replicate between regions, so that's great. So mounting an S3 bucket using NFS is not recommended. Well, you can't access S3 with NFS. You access S3 with HTTP and HTTPS mostly, or a command line API. So NFS is, you mount EFS connections with NFS. So you're sort of mixing two technologies there, Phil. Yeah, so Santosh asked a good question. If you shut down your instances and then start them up the next day, you won't pay for the instance hours, but you pay per month for the EBS volumes. So you definitely get charged for them. And you get charged for the EIPs. There was a question last week about that, I think. You get charged for the EIPs when the instance stops. So if you've got an EIP on it, you probably go backwards, shutting them down. So, yeah, that's why we talked about last night, the T3 type instances might be good for development because they are a lot cheaper. And when you're not using them, your credits are building up. So that's helpful. We'll see where we're up to. Does S3 use auto failover for another region if you have a? Yes, it does. So if you've got your folder, your bucket replicated, and you use that global URL, it's Amazon's problem to go and find the file for you from wherever it still resides and still working from. So, you know, you get some pretty nice things from AWS like that. What's the best approach in trying to balance IOPS and bandwidth for database usage? The best answer to that is put your database on RDS, Bruce. So almost always push your databases to RDS. It's a sort of a pet hate of mine, people running, trying to save a buck, running your database on an EC2 instance, really is just asking for trouble. And if you, once you get into higher bandwidths and higher IO usage on things like provisioned IOPS, you really need to understand your instance types. And some instance types have got higher EBS performance than others. And so you've got to look into that. Any snapshot number limits? No. You can snapshot forever and a day, RAM. And I really like snapshots. They're quick, they're instant, they're reasonably cheap, and they're only incremental. So if you create a snapshot every day, the first snapshot, say you've got 100 gig volume, you've got 10 gigs of used data, and you snapshot it, Amazon gzip compress it and it'll be 6 gigs. So you still to actually find out how big they are. And the next day, you might only update 1 gig of data. And if you do another snapshot, we'll only get incrementally, that 1 gig will get zipped. So 5 snapshots will only probably take the same size as the original one plus 10% or something. Depends on how much data changes. But the incremental nature means you can take a lot of snapshots and it doesn't cost too much. Oh, someone posted someone where someone installs some snowball drives, but the data should all be encrypted anyway. So as far as I know, once you put in the snowball, it's encrypted. So I assume that you couldn't get any data out of it. What category does in-memory storage come under? Yeah, AWS it comes under database stuff. They do have some in-memory databases, and do we do databases? I think we do. So they've got some Redis type things, and they call it something else. I can't remember off the top of my head what it's called. But there's plenty of NoSQL type databases that Amazon will look at on the RDS week. Can S3 be used like a CDN? Well, good question, Paul. No, not really, because they've got a special CDN product called CloudFront. So you use CloudFront for being a CDN. But a lot of people, if you've got large downloadable files, move them off the website, like I said, and put them on S3. So it's not hammering your website just to download these big files. All right, I think that's all the questions. Do you have any examples? Sorry?
No, that's okay. Beauty. So next week we're going to be talking more about databases. So another chance for you to reiterate about the RDS.
Yeah, put your databases on RDS.
Yeah.
See how many people ask about where should I put my database in EBS and IOPS, but you know, it's just that you're just going to get that question wrong, and you're going to give your client or your corporate the wrong steer if you're putting databases on EC2 instances. It's so common, and I just think you're just doing the wrong thing.
Okay. Well, I look forward to hearing more about that next week. If you have any more questions through the week, gang, feel free to chuck them in the forums. We check them every couple of days, and I know Scott's been on there.
Yeah, I've been answering a few questions on the forums.
Yeah, it's really great.
I think when other students have answered it well, I don't bother chiming in. If I've got something interesting to say, I'll try to add into the conversation.
Yeah, and that's the best thing about it. There's 5,000 students enrolled in the short courses, so
yeah.
Plenty of insights out there.
I've tried to make 4 pretty hard questions this week and 1 pretty easy one for the quiz. But as you saw last week, there's tricky little bits to the quiz questions, so they're not too easy. But I think they're very similar to some of the certification questions, some of the harder certification questions, which is why I put them in there. So you get a bit used to answering and understanding how they ask questions.
Yeah, that's great. Is that going to be the same sort of case for the exam questions?
Yes.
At the end of the short course?
Yep.
Yeah, sometimes we have very easy exams, folks, so make sure you study up before taking this one. All right. Well, thanks so much for another excellent lecture. That which I understood was very interesting. Thanks a lot, Barry and Angus, for joining us from IT Masters. We'll catch you all next week. Thanks for joining, and thanks a lot, Scott.
Okay. Thanks, Scott.